Hi Seahawks, welcome to the 8.6 even and odd functions video. Alright, so in this video we're going to talk about even functions and odd functions and how to identify if they are each one. So if we're talking about an even function, you can see on the left side here that both tails, both end of the equation, are pointing in the same direction. And the other way to test it is also that your x value for the positive x side is the same x value on the negative side with the same y value for both. So for example, if one side was 2 comma 5, then the opposite side would be negative 2 comma 5. So it's going to have the same y value, but just the opposite sign for the x value. And if it does, then that means it's an even function. If it's odd, that means that the tails are open in opposite directions. So one's pointing upwards, the other one's pointing downwards. And in order to determine that it's an odd function, you would also have to switch the x values to the opposite signs and the y values. So you can see where that yellow dot, for example, if that was 2 comma 3, then the yellow dot on the left-hand side would be negative 2 comma negative 3. So both the x and the y both become negative on the opposite side. So if they are, and that is an equal distance on the left and the right, then that would be an odd function if both the negative x and negative y. And then even function if just the x is negative on the opposite side. All right, so now it wants us to determine if the functions below are even, odd, or neither. So we have f of x equals x to the fourth plus x to the third. So you have to switch the x values so that they are minus on each one. So negative x to the fourth, negative x to the third. And if you multiply negative x by itself 4 times, that ends up being a positive x to the fourth. And then if you multiply negative x by itself 3 times, because it's negative x times negative x times negative x, it makes it back negative again. So then you end up with x to the fourth minus x to the third, and that is not the original. The original had a plus sign right there. So because that's a plus sign, that means that it's not the same, so it can't be even or odd, so it's neither. The next one is x to the sixth plus 1. So remember, we're only changing the x value to negative. We're not changing the 1, obviously, because that's not an x value. So negative x to the sixth power. Well, anytime an exponent's raised to an even number, it's going to be a positive answer. So that would be x to the sixth power plus 1, which exactly matches our x to the sixth power plus 1 over here. So therefore, it is even. Then the last one, we've got 6x to the fifth power minus x to the third power. So we're only changing the x value. So we have 6 times the quantity negative x to the fifth power minus negative x to the third power. Now remember, that minus is part of the problem. It's not what you're changing. You're only changing the x. So that minus a negative x changes to a positive. So we have 6 times negative x to the fifth power. Well, anytime it's odd, makes that a negative x to the fifth power, or 6x to the fifth power. And then negative x to the third by itself is negative x to the third. However, because it has that minus sign in the middle, it changes to positive. So because both the negative 6x to the fifth is the opposite of 6x to the fifth, right here what I'm talking about. So because this is the opposite and our x to the third is the opposite with a positive 1, therefore it is odd. When both of them change, then it's odd. All right, so we have some special properties that we need to go over. So when you're adding two even functions, it's going to be even. When you're adding two odd functions, it's going to be odd. And the sum of an even and odd function is neither even nor odd. So for adding, if they are the same, then it's going to be the same. And if they are, they're both even, they stay even. If they're both odd, then they stay odd. And the sum of an even and odd is neither, ends up being neither one. And then for multiplying, the product of two even functions is even, and the product of two odd functions is also even. So if for multiplying, if they are the same, then they're even. So if they're both even, they're even. If they're both odd, they're even. Only when you're multiplying the two functions together. And then the product of an even function and an odd function is odd. So when they're different, then it's odd. When they're the same, it's even. That's only with multiplying. And then an even and odd, so a function can only be even and odd if the function equals 0. So if it's equal to 0, then they can be both. All right, on this side, we need to do determine whether it is even, odd, or neither. So taking a look at x to the fourth plus x to the third, well, that's an odd plus an even, so it is neither. And the next one, x to the fifth plus x to the third, that's an odd plus an odd, so when they're the same, it's odd. And the next one is x to the fourth plus x squared, so they're both even, that makes it even. And the one on the right hand side, 6x to the fifth minus x to the third, they're both odd, so it's odd. Then we have 3x to the fourth minus 4x to the third, one's even, one's odd, so that's neither. And then we have x to the fourth plus x to the third, one's even, one's odd, so that's also neither. And then down here at the bottom, we've got to determine if their product will be even, odd, or neither when you're multiplying them together. So they give you three functions to work with, f of x, g of x, and h of x. So you have to determine before you can start whether it's even or odd. So x squared plus 1, well, that 2 tells us it's even. X to the third minus 3x, that 3 as the exponent, tells us it's odd. And x to the fourth minus 4x squared, that 4 as the exponent, tells us it's even. So now for the first one, f of x times g of x, well, f of x is even and g of x is odd, so even times an odd. When they don't match, it's odd. Next one, f of x times h of x, so f of x is even, h of x is also even. When they both match, it's even. G of x times h of x, so that's odd times an even, and when they don't match, again, that's odd. And then the last one has all three multiplied together, so that's even, odd, and even all multiplied together. So when you have even then odd, it would be odd, and then when you multiply it again by an even, because they don't all match, it's odd. And that's it. Go Seahawks.